Hey everybody, my name is Jason, also known as Pirate JC, and welcome to another Babylon video. This is part 4 of our epic video series entitled A Tech Artist's Journey, where we are taking a curvy, twisty adventure together, like a hike through the woods, to create this dancing morph target demo. Now, the purpose of this video series is not to take the most direct path to creating something like this. It's actually the opposite. It's to explore some brand new concepts and ideas. It's to combine things that maybe we haven't thought of combining before. The point of this series is to learn something new. So if you catch yourself asking, why are we doing it this way? That's why. Simply because we can, and we're going on an adventure together. We've covered a lot of ground so far. We've been in Blender for 3 videos where we started with learning how to make a mesh, learning how to create shape keys for that mesh, create multiple UV sets for that mesh, and then we learned how to use Blender's Python API to interact with the scene and batch rename things for us, saving us time and effort. And then finally, we used Blender's fluid simulation system to create animation for us. This video will be our final video spent inside of Blender before we move on to Babylon. And this video is all dedicated to capturing the animation that we created with the fluid simulation. Without any further ado, let's go ahead and dive right on in. This is where we left off in our last video. And again, the purpose of this one is to capture the animation here that we have in this awesome fluid simulation. Remember that we set up a height map, a gradient that we could put onto our geometry so that we could essentially render a height map when we look through this camera. So now what we're going to do is we're going to turn to an amazing tool inside of Blender called the Compositing Tool. If you go up to the tabs at the top, you'll see it. It's the third from the left by default. The third from the right by default, excuse me. So we're going to click on that. And what you see in the beginning is actually not super exciting. We have to do a bit of setup here. And I'll walk you through the setup that I like to use when I'm using the compositing tool. The first thing is I want to use nodes. So I'm going to click on nodes. We'll go ahead and I'll show you what I like to do next. If you hit Shift A to add, and then we go type in viewer, and I want to add a viewer, notice that I get a node and I get a goofy black box behind the nodes. Let's place the node and connect it up. And with our slider, our time slider somewhere around like 48 or something like that, I'm going to hit render, and you'll see that that basically gives us a preview, the viewer, of preview of the render. So what's happening here, I want to dissect this with you. What's happening here is we're taking the render itself and we're passing that through a compositing tool. In this case, it's really simple. We're simply saying, go give it to a viewer. But all of this cool, amazing stuff can be done inside of this tool. You take your render and you can do non-destructive post-processing on it. And that's incredibly cool. All right, let's continue setting up here. I don't actually like this, this viewer back here, so I'm going to hit backdrop. I'm going to turn that off. And instead, I want to change this window down here to be the image editor. And I can do that with this little drop down. I'll change it to the image editor, and I'm going to go look at the viewer node. And so what I've done is I've moved my preview down here, okay? I'm going to move this up just a little bit, give us a little bit more real estate so that I can get some of the time slider in here, because that's going to come in handy later. So as you've probably guessed, the work that we're going to be doing here is all between the render layer and the output viewer. And essentially what we're going to be doing, this is a crazy concept. The first time I heard about this and wrapped my head around it, it kind of blew my mind. We are going to take an overhead render of all of we have essentially 30 frames of animation. Basically, here I'll show you that real quick. We'll go back to the layout tool real fast and I'll just show you. We essentially have 30 frames here, starting about frame 34 if you've used the same settings that I have. Yours might look a little bit different, but I'm basically starting from the first frame of all black all the way to the last, the first frame, the last frame of the animation, which is the next first frame of all black. Okay, so basically it's frame 34 to 64, so we have 30 frames right there. So I'm going to go somewhere in here to start just so that we can get set up properly. We'll go back to that compositing tab. Again, I'm going to hit render just so that we can see exactly what we're looking at here. And so the magic, the crazy thing that we're doing is we are going to find the highest point of every frame of all of those 30 frames, okay? Essentially, what we want to do is there's going to be a pixel that represents the highest point, the highest value of that abyss-like structure, that abyss-like spire of liquid. And what we want to do is we want to isolate it, and then we want to create, what we're going to do is create a tiny itty bitty little texture, 1 pixel tall by 30 pixels wide, where each pixel stores the highest point of this abyss spire animation. So effectively what we're going to do is we're going to capture this animation and store it in a texture. That is such a crazy concept to me. It's new to me and exciting. And we're going to go through the entire process here using Blender's Compositing Tool to basically take that animation and store it in an image format. What a cool idea. Okay, let's do a couple of quick things real fast before we start building out this compositing tree. Let's go to our output settings here, output properties, all right? And I want to go ahead and change the frame range to be the one that I'm looking at. I want 34 to 64. And then I also want to set the properties of the output. This is very important. For the color depth, we need 16-bit color depth, okay? That's a very, very important thing. We also want PNG, and we're going to want the alpha channel as well. So that's RGBA. Okay, so that's effectively all set up for us. The last thing we need to do is we're going to render things out and then reuse them and composite them. We need to set up a directory for where we want our renders to go. I'm going to do that. I have a place set up for me here in renders, so I'll accept that. Once you've done that, you're pretty much good to go and we're set up, and we can start the process of identifying at any given frame what's the highest point and then storing that into a tiny little texture. So let's go through that now. The first thing to notice is the values that we're seeing here. We're seeing black, obviously. If you right click on an image, Blender gives you the values of it. You can see that right below here that it's RGB of 0 and an alpha of 1. But as we climb up the spire, we'll see that the RGB values slowly increase until they end up at, looks like maybe 0.61, somewhere in that range is the high point, I think. Somewhere around there, 0.61. Well, what we want to do is we want to identify the highest point. And so to do this, we're going to start by normalizing this. What normalization is it takes a range of values and it stretches it between 0 and 1. So in this case, we know we have something that's 0, but we don't have any values that go all the way up to 1. So what it'll do is it'll find the highest pixel, the pixel with the highest value. It'll stretch that to 1, and it'll stretch the values of everything else accordingly. And we can do that. I'm going to hit Shift A here, and I can search for the Normalize node. And then I can drop that right in. And in Blender, you can hover over a spline, and then you can drop it, and it'll connect it right up. And now when I right click, you'll see that I have 0.9975. Somewhere in here is a pixel that represents 1, has a value of 1. And that's what we're going to find now. And actually, it's really easy to do. We're going to add a math node, and we're simply going to say, and again, I'm just hovering over and then clicking to drop it in. I'm going to change the operation of this math node to be a greater than, and I want to look for anything that is greater than 0.59s. 99999, and I'm going to hit enter, okay? And you might have a hard time seeing this, but as I zoom in, I can tell that there is a single individual pixel here, and if I right click on it, it has a value of 1. And that is what we're after. So we essentially now have a pixel mask, a mask that effectively says that single pixel has a value of 1, everything else around it has a value of 0. And we're going to use that as a mask. So what we'll do is we'll duplicate this greater than node, okay? We'll Shift D to duplicate. We'll bring it up here. We're going to change the operation to be a multiply. And so now what I want to do is, even though I know the exact pixel, the XY coordinate of the pixel that is the highest value of my rendered image, the value is not true. We manipulated the value, and I want to grab the real actual height value. So we're going to multiply the original image, which has the original value, by this new mask here. And what that will do is when I switch it over, let's check this out. I'll find that pixel. There it is. Has a value of 1 right now. But when I go hook up the viewer to it, watch what happens. It's going to drop in value back to that 0.61 that we saw before. So that now has given us a mask and an ability to find the exact pixel of our original image that is the highest value. Pretty cool, right? Okay, the next thing we want to do is we want to get rid of all of the black. We just want that to go to transparent, okay? So we're going to hit Shift A and we're going to grab a node called Set Alpha. Okay, and the Set Alpha node, we're going to pass in the output of the multiply as the image. And then we'll connect it up to the viewer. And for the alpha itself, we're going to use the original mask. Okay, now watch what happens. When we do this, oops, I connected to the wrong one. Sorry about that. We'll connect it to the alpha. When I do that, you'll notice, there we go, that single pixel is now by itself. Everything else is 0, 0, 0, 0, and this is its 3 RGB values plus an alpha of 1. And that's what we're looking for. All right, the next thing that we want to do is we've got this giant canvas with a single pixel in it. We're going to flood that canvas with the same value that exists for that pixel. And we can do that with one single node called InPaint. So we'll drop this right in, and I'm going to set the distance. Actually, here, I'll just show you what happens with InPaint. I can move this up, and it'll slowly start to just expand it. So I'm going to give it a value of 1,000, just something nice and big, and that will flood the entire canvas with that single value for that original pixel we had. And there you go. And no matter where I go, the value stays the same. So now we have an image that is 500 pixels by 500 pixels, and every single pixel has the exact same value, which is the highest value of our original rendered image, okay? So now what we want to do is we need to start to compress this down to our little itty bitty texture, our 1 pixel tall by 30 pixels wide texture. And so here's how we're going to go about doing that. The first thing we want to do actually is at this point, we're going to hard code the alpha into this, back into this, okay? We're going to go grab a Set Alpha. You can also just duplicate it. I'm going to drop this right in there, and then I'm going to hit Shift A and grab a value node. And what I want to do is I want to set that value to be 1. I want to drag this over, and then the mode for the Set Alpha is Apply Mask. I want that to be set to Replace Alpha, okay? And when we do this, effectively, this is setting it up so that we can effectively have our individual pixels, our individual values for each frame of animation mapped to a specific pixel. And we're doing that by making sure that any pixel that goes to completely black, it doesn't end up transparent. We actually want to write out that it is 0 height, okay? And this helps us do that. So what we'll do now is we'll grab a crop node. Again, we'll plop that in right onto this spline. We're going to say we want to crop the image, and we want it to be 0 on the left, 30 on the right, and then 0 on both up and down. And if I get close to this, you can see now that I have a single strip, 1 pixel tall by 30 pixels wide. And I want the ability, I need the ability in this to be able to move this for each frame. So as I go forward a frame, I need to move it because I want pixel 0 to be the first frame of animation and pixel 30 to be the last frame of animation. So we're going to do that by grabbing a transform node and dropping it in. And now if I go through and I give this a random value, you see that it moves over, and that's the desire that we want. We'll start it by just leaving it at 0. And actually what we're going to do, and this is an amazing feature, is we're going to go grab another value node, okay? And we want to go to the start of our animation, the very first frame, frame 34, and we're going to set a value of 0. And then watch this. You can key these values. How crazy is that? I'm going to insert a keyframe here at 0. I'm going to go to the end of our range at 64. I'm going to set that to 30, and I'm going to key that as well. And then down here where you see the actual key markers, I'm going to right click and set the interpolation mode to linear. Because what I want it to do is I want to make sure that every frame, it just steps up and goes in a complete linear fashion right to from 0 to 30, okay? And so we'll set that to linear as well. So now, if I take this and I move that in as the X transform, watch what happens. As I'm at 64, it moves, but as I move, it's actually moving around. How cool is that? That's kind of amazing, right? Now, it's just moving the same image. If I wanted to see the actual render at frame 38, I'd actually have to run a render, and there we have a new value. But the point is that as this goes along, it will move according to what frame it's on. And that's an awesome thing that's going to come in super handy for us, okay? All right, so we're actually going to start here. We're going to render this, and we're going to get black to start. And now what we want to do is we want to write this to disk, okay? We're going to render out each one of these as a separate individual element. So the first one will look like this. The middle one will look something like this, so forth and so on. And we just want to render out each one, and then we're going to start to combine them together. So let's go to frame 34. Now we can do this, if you've set everything up correctly, we can do this by grabbing an output node and grabbing a file output. And you'll notice that because we set our output directory earlier, when we bring this node in, it's automatically set for us. And so I'm going to take the output of this transform, I'm going to take it right to file output. And now what I can do is I can say render animation. Now this should go pretty quick, shouldn't take too long, and it's actually rendering it out with different values, and you can see it go live there. Okay, so now we're in an amazing place where we've done our renders. We have captured the highest point of the animation on any given frame. Now we just need to stack that together. Now this part is a little bit manual, but it goes pretty quick. So we're going to do this by actually moving past that tree and creating a very, very simple new one. So we'll zoom out a little bit, give ourselves some space, and we're going to start by Shift A, and we're going to grab an input. Okay, we want to grab an image. And what we want to do here is we want to grab an image sequence. Now to do that, you go to your renders. It renders out both the individual renders as well as the outputs of the composite. So my composites start with the word image. So I'm going to grab all the images and I'm going to load them in as an image sequence. A couple of interesting properties happen here when we do this, okay? You'll notice that it tells me how many frames and what the offset is. I need to tell Blender, where does this start? It's going to start at frame 34. And so now at frame 34, actually, let's do this. Let's hook up the viewer directly to this. And we should see that as we go forward through each frame, we're actually seeing the individual images of the composite that we just wrote out. And the last one, of course, will be black. Okay, so we'll go to frame 34, and we're going to write this out. Now, this is very, very important. We're going to say image save as, okay? We can save it anywhere. This is really important. You need to make sure that you have RGBA 16 and you want to click off this save as render. We do not want that. Save it as any name. It doesn't matter. We're going to overwrite this each time, but this is going to start as our animation.png, and we'll hit save as image. Now what we want to do is we want to go bring in another image, okay? Input image. And this one is going to be the image that we just had. And what's going to happen is we're effectively just going to do basically a mini composite where we treat each one as a layer, and then we flatten it, save it as we move along. Now, the truth of the matter is what we're about to do is probably a lot faster to do in a Photoshop or a GIMP or something like that. But we're here in Blender, so I want to teach you how you can actually do this, how you can write out and reuse this. So what we're going to do is we're going to go grab one more node called a set alpha. And then, nope, sorry, that's the wrong one. I apologize, not set alpha. We want alpha over. That's what we want. It wants to take the background image first. So that'll be the one that we saved to disk. And then it wants to overlay on top of that the foreground image, okay? And now when I hook up this viewer, you won't see anything remarkable at all. It'll look exactly the same because we're still on frame 34. But when I move to frame 35, watch what happens. Now we're starting to see what we want to see. It's loading in the image sequence that we wrote out, and it's overlaying it right on top of the saved out image that we just did. Okay, so let's go through this one more time. I'm going to hit Alt-S to save. I'm going to click off Save As Render. I'm going to Save As Image, and then I'm going to load that same image again. And now when I step forward, boom, we have our third value for our third frame of our animation being written out into the texture. So at this point, I'm going to actually ask you to just go through this process. However long the animation is that you've chosen, just go through. It's a bit manual. You're just going to save, make sure save as render is checked off, and then you're going to load that into the background image. And you're just going to go through that until you get to the very end. So I'm going to fast forward this video so you can pause now and do this yourself. And when the video starts back up again, we'll do one more thing to get our texture, our animation completely ready to use, okay? So you can either do this on your own, listen to some music, whatever it is that you want to do. I'm just going to run through this process, all right? Okay, welcome back. If you just finished up doing all of your animation, that's awesome. Before we can use this, there's one more thing that we need to do, okay? We want to make sure that we're loading the absolute final one that goes from black all the way to black. And what we're going to do is we're going to normalize this final image. Basically, we know that we start at black, but as you scroll along here, you'll notice, remember, we don't, our little abyss spire, it never really makes it up perfectly to 1, to a value of 1. And so what we want to do is we want to do, in fact, in this case, it makes it to a highest value of 0.5 something or other. And so what I want to do is I basically want to stretch all those values out, normalize them between 0 and 1. And as you've guessed, it is incredibly easy to do by just using that same node we did in the beginning, the Normalize node. And so I'll drop it right here, and I'll take in our image and I'll go to our viewer as an output. And you'll see that now we actually have 0.99, 0.998. There's 1. There's our highest point of our animation. And then it starts to drop all the way back down. So now we have perfectly captured our fluid simulation as a texture, our animation as a texture, and then we normalized it to make sure that it goes between 0 and 1. Because what we're going to do is move this over to Babylon, where we're going to tell Babylon that we want to use the value from this texture to create an animation to then animate the influence of the shape keys over time. Isn't that so mind-boggling? I mean, how cool is that? Okay, so last thing here, I want to make sure that we save this normalized version. Again, don't save as render. By the way, to explain why I don't save as render, I don't 100% know what it's doing, but that save as render is doing something where it changes the values. I think it makes some assumptions to be helpful, but in this case, it really is not helpful. Also, I know that what we did was a bit of a manual process. I actually tried to figure out how we could automate this myself. If you know, I would love for you to comment down in the comments of this video to tell us how we can go about automating this once we've written out all these individual textures. I'd love to be able to like compress a bunch of images together in Blender. And maybe there's a super easy way to do that. I just haven't discovered it yet. But now what we have is our normalized texture that has captured all of the animation from our fluid simulation. To get it into Babylon, we're going to use a crazy simple method. We're going to basically attach it to our object and then export it, okay? So we're going to go all the way back to layout, and we're going to hide our camera and our fluid simulation domain, and we'll turn the bars back on, okay? So this is the original mesh that we created in our first couple videos. We're going to go to shading, and with our bar selected, we're going to create a new material, okay? And that material, we'll just call it bar material. For now, again, Blender defaults into bringing in the BSDF shader. That's fine for our purposes for this one. So we're going to hit Shift A. For texture, we're going to go down to texture and bring in an image texture. And we're going to open that tiny little texture that we saved out. Okay. If we pass this straight across to the base color, watch what happens. Now we have mapped the texture that has animation values stored into it. And we've just passed that in as a material because we'll actually make the bars, the dancing bars, will change their look inside of Babylon. So for now, all we need to do is take that baked out simulation animation that we stored as a texture, and we need just to pass that into Babylon. We can do that by passing it with the bars themselves. So one single object that gets loaded into Babylon has all of this cool stuff baked into it. How cool is that? I absolutely love it. Let's turn specular all the way down and roughness all the way up. It doesn't really matter because, but just because we're using PBR here, just be a little bit easier to look at without shining on us once we get it into Babylon. Okay, so effectively now we are at the point where we are ready to get this thing out. And to do that and get it ready to use in Babylon, there's only one final thing that we need to do, which is a very simple export. File, export as GLTF 2.0. And basically, I'll walk you through what I want to do here. I'm going to set it to bars. I'm going to change the values to be selected objects. I like to export as a GLB format, which is basically a packaged GLTF file. We want selected objects. We want Y up. We do want UVs. We don't care about vertex colors. And then under animation, we don't need any animation. Of course, we do want shape keys and we don't need any skinning. And so now when I hit export, I am ready to go. It has written out the bars and we are absolutely ready to go and check these out inside of Babylon. The video is actually going to stop there. We're going to stop before we move into Babylon. But as a special little tiny treat, I know you're probably so eager to see the work that you've done inside of Babylon. So why don't I show you how to do that real fast? What we can do is we can go to open a new tab and type in sandbox.babylon.js.com. Open up the parent directory where you have your bars. I have them right here, and I'm just going to drag that bars.glb directly into the sandbox and check out what happens. Nothing. Just kidding. Just turn the camera. And there they are. Drag and drop right into Babylon. How cool is this whole entire adventure? We're doing some crazy concepts, combining some goofy things, using awesome tools, and we're slowly making our way towards making this really cool demo of these dancing morph targets. Thank you so much for coming along on this journey with me. I hope you're learning something from it. If you haven't already done so, please consider subscribing to this channel so that you don't miss any future updates. And we'll, in the next video, move on into Babylon, and it's going to start to be real fun, real fast. Thanks again for joining me, and we'll see you next time.